This presentation looks at the classification of programming languages. High-level programming languages is closer to the human language and is therefore easier for humans to understand. But a translator is used to convert the instructions into code that the computer understands. High-level languages allow programs to be written that is independent of the type of computer. Also, high-level programming languages allow code to be written that is independent of the type of computer system. So it's up to the compiler to translate the code into the right machine code for a particular machine. There's a huge variety of high-level programming languages, and really the choice of language really depends on the application. Low-level programming languages refer to machine code and assembly language. The low level refers to the low level of abstraction. Low-level languages are close to the language understood by the computer, where operations map to the instructions in the processor instruction set. However, it's difficult for humans to understand. Low-level languages are appropriate for developing new operating systems, embedded systems, and hardware device drivers. Machine code is expressed in binary values of 0 and 1. This is the language that computers understand directly. All codes, whether assembler or high-level languages, need to be translated into machine code. Machine code is specific to a processor. Machine code instructions are made up of two parts, the operator and the operand. So the processor decodes the operator to identify the task that is to be carried out, for instance to add, to load a number. The operand is the actual value or memory address that the instruction is to be operated on. Assembly language provides basic computer instructions for programs to run. There's a one-to-one relationship between machine code and assembly code instructions. One assembly code instruction maps to one machine code instruction. Thus, the structure of assembly language and machine code is the same, but where machine code uses zeros and ones, which are very difficult for a programmer to understand, assembly language uses names which are easier for the programmer. Each type of processor has its own instruction set and therefore its own assembly language and machine code. So assembly code written for one type of processor will not run on another. So the disadvantages of low-level languages is that they're very difficult to understand and modify. Assembly code is written for a specific processor type and so is not portable to other computer architectures. The advantages is that low-level languages produce code that is faster and better optimized than high-level languages. Low-level languages are appropriate for developing new operating systems, embedded systems, and hardware device drivers. The advantages of high-level language are that they allow code to be written that is more portable. This means that code can be written on different types of computer systems with different processor architecture. High-level languages are easier to understand and they're easier to modify. Disadvantages are that they need a translator and they also run slower than low-level languages because of the layers of abstraction, and there's normally an inefficiency in the translation process. So program translators allow programs to be translated into machine code so that the programs can actually be run on the computer. So there's different types of translators: an interpreter, a compiler, and assembler. So we're going to look at an interpreter first. So an interpreter converts high-level languages into machine code, one instruction at a time on the fly while the program is running. Each instruction is converted to machine code once the previous instruction has been executed. Interpreters are good for debugging code because the program stops as soon as an error has been found. However, running code this way is much slower than running compiled code. Machine code is not usually saved. With a compiler, a program that converts high-level languages into machine code before the program is run. So this is what the compiler does. The compiler saves the machine code, so the source code is no longer needed. A compiler allows a program to be run faster than interpreted code. Software is normally distributed as compiled machine code. For proprietary software, this is good because other people can't copy the code and use it for their own applications. And finally we have assembler. So assembler converts from assembly language into machine code.